Before we get further into some of the hands-on videos, we'll take a brief look at some of the concepts that we need to be familiar with if you're new to virtualization, or maybe you're interested in learning a bit more about the limitations from a hardware perspective of vSphere 5.1. So in this section, we're going to take a look at why we may want to virtualize, the concept of a hypervisor and what it does for us, and particularly ESXi in this case. We'll talk about the combination of vCenter and vSphere, the hardware limits for servers running ESXi, and the limits of the virtual hardware that we can present to virtual machines. We'll take a little bit of a look at some of the features of ESXi, and we'll talk about the importance of integrating with your storage and network, and some of the things that you're going to want to keep in mind as you start thinking about how you might apply vSphere 5.1 to your environment. In traditional non-virtualized solutions, we end up with a lot of times one application running on one physical server, or maybe even one service being provided by many applications running on many different servers. Typically, we're not going to want to mix various applications on the same installation of an operating system and an application environment because there may be incompatibilities between those applications. They may not have the same maintenance requirements. We may not be able to run them together, or we just may not be able to take some of our older applications on more modern operating systems. And when we start doing that, it gives us a fairly easy way to avoid having changes to one application break another. But doing that using physical servers is going to require more physical space, more electrical power, more cooling capacity. We end up spending quite a bit of time doing lifecycle management of those servers in terms of aligning ourselves with warranty coverage and replacing those servers before their warranty coverage becomes expired. But then we end up practically having to do lifecycle-oriented refresh migrations on an ongoing basis. And at a certain point, it gets difficult to support legacy applications and operating systems on more modern hardware. So when we move into a virtualized environment, we can take a lot of those applications, which may have been running on a physical server in order to maintain their separate configuration environment, but they may not really be using the resources of that server effectively. We can consolidate those services into virtual servers running on physical servers, but at a higher consolidation ratio. So that's going to potentially, anyway, greatly reduce the number of physical servers that we have in our environment. That's going to help us reduce our power consumption footprint, reduce our cooling footprint, and overall move toward a more green data center that's more efficient and also more dynamic than what we would typically have dealt with before. That's going to help us separate the physical lifecycle management of servers from the longer-term lifecycle requirements of our applications. It's also going to help us with testing and deployment cycles because we can provide a test environment much more easily, and we can potentially move from test to production environments more easily as well, or with a higher degree of confidence and just much more efficiently than we could have done before. For troubleshooting purposes, we can also easily create virtualized copies of our applications and create one-off environments in order to simulate the environment for a migration or to help troubleshoot and do root cause analysis of a problem. So overall, it's going to allow us to more quickly deploy services or more quickly deploy new capacity for existing services easily and efficiently. And it's also going to allow us to migrate virtual machines from hardware resources on one server to another quite easily, potentially even online using something like vMotion. Again, a complete separation of our hardware infrastructure lifecycle maintenance and management from our application lifecycle maintenance and management. In order to do this, we're really looking at using what's called the hypervisor. When we talk about virtualization in a modern context, it's important to understand that we're not talking about emulating or simulating physical hardware in a virtual way, but really more taking a very similar virtualized environment to the physical environment and providing a layer to handle demand to resources and so on. We're only able to run, in the case of VMware, x86 and x64 type operating systems, 64 or 32-bit Intel AMD style architectures, running an operating system designed for those architectures with applications designed for those architectures, and in the end, physically running on that type of architecture. So we're going to be using x64 hosts, so 64-bit Intel AMD style instruction set systems, running either 32-bit or 64-bit guests. We can't run Itanium applications, something like OpenVMS for Itanium. That's simply not possible. Providing virtualization across disk-like platforms is actually very, very difficult to do because we really would have to simulate in software everything that the hardware would typically provide and then translate between those different instruction sets. We really have to think more of the hypervisor as providing more of a pass-through type capability where much of the hardware is virtualized. And in fact, we can even use para-virtualized devices to reduce the overhead of doing that. Although virtual machines typically see very generic hardware that's separated from what's actually running in the host, they do get a fair amount of visibility to the CPUs that they're going to be running on, and they're able to adapt their memory layout and so on to the capabilities that they leverage to what's available physically on the hardware. So it's really the thinnest possible virtualization that we want to achieve. And one part of that is ensuring that our virtualization services or the hypervisor services have the best performance that they're capable of providing. And the way to do that really is to run it as a bare metal operating system where the hypervisor has complete control of all the hardware resources. And ESXi works in that sort of type 1 model where it runs directly on the hardware as Windows typically would on a physical server or otherwise, compared to, say, VMware Workstation, where we would install Windows or Linux or some other operating system that VMware Workstation is available for, and then just run VMware Workstation as an application on that system. Then we're not going to get the same level of performance. We're not going to get the same level of capability. So when you look at Type 1 hypervisors such as ESXi or Microsoft's Hyper-V, they're going to provide the best capability to provide that low latency, minimum overhead-based virtualization that we'd like to achieve. And then the virtual machines themselves use pretty generic, widely compatible virtual devices for things like SCSI and IDE adapters and things like Ethernet. They're going to be well supported by the operating systems that you install. For example, a bus logic SCSI adapter that might be better recognized by Windows NT compared to a QLogic serial attached SCSI driver, which might be better recognized by Windows Server 2008. We present a BIOS, we present a chipset, we present a couple of different types of NICs and SCSI adapters depending on the needs, and the guest operating system has to provide support for those devices. And we also need additional support for the various virtualized devices, some of the special memory management and things that VMware is going to want to do. We're going to need to get specialized drivers installed for that in the form of VMware tools. So VMware ESXi replaces the previous VMware ESX as VMware's bare metal hypervisor, designed to reduce the footprint of the installed operating system that VMware operates with. In ESX, it was effectively pretty much a full-scale Linux distribution with quite a few packages and tools and utilities installed that were not necessarily commonly used in a VMware environment, but were provided to make it easier to support the Linux-style environment that VMware uses in a way that Linux administrators would be familiar with. But of course, that led to an expanded disk footprint and also an expanded security attack surface. So a lot of that has been reduced to the absolute bare minimum. So there is still a minimal Linux environment that ESXi uses for system startup and basic file system management and things like the etc file system structure or the user file system structure and so on that Linux and Unix file systems use, as well as things like rc.d startup script system and so on. And then we have VM kernel that really takes over the core management of things like processors and memory and disk I/O and network I/O and so on. It's not really based on the Linux kernel, although there are parts of the Linux kernel used to start up the system. In ESXi, we do still have a Linux environment, but it's really designed to be as minimalistic as possible, so there's no support for installing Linux applications into it and so on. You may be able to do that if you start installing various tool sets and so on manually, but for example, there's no support for a Linux-style package manager for things like Debian packages or Red Hat packages, so it's going to be difficult to do that. Potentially it could be done, but really as a best practice, we should try to keep absolutely all non-VMware components out of that environment. And we should move towards things like VMware management agents, which are virtual machines which are used to manage the localized installation of ESXi itself. It's quite interesting as you move into, say, the Enterprise Plus, you can actually not install VMware ESXi at all and boot off the network each and every time using something called auto deploy with various deployment rules and host profiles and so on. Or we can install ESXi onto USB or flash media or a traditional installation with local hard drives, especially if we're going to run virtual machines from the local hardware and not from the SAN. But if we're going to run all of our virtual machines from shared storage, then having the minimal footprint maintained on the local server is really going to be for the best. So in terms of the limitations of ESXi 5.1, we can see that they're quite high and they've been increased quite a bit, almost double or more in some cases from what we had in, say, ESXi 4.1 or ESX 4.1. So we can see that we can have up to 2,048 virtual CPUs per host, up to 160 logical host CPUs, which would be really cores, and or hyperthreading, which will be seen as 2 logical CPUs, up to 2 terabytes of physical memory in our ESXi servers, up to 512 virtual machines on one ESXi server, up to 2,048 virtual disks on 256 different storage LUNs that are presented from local storage or iSCSI or Fiber Channel. And those LUNs will typically, unless it's something like an NFS data store, if it is actually seen as a disk, we're going to format it as the VMFS5 file system, and each of those volumes can be up to 64 terabytes in size. So we can create some fairly large servers and achieve some fairly high consolidation ratios. And if we look at what we can actually do in terms of the virtual machines themselves, we can actually see that even one single virtual machine can have up to 1 terabyte of memory, 64 virtual CPUs. Each disk can be up to just slightly less than 2 terabytes in size, up to a terabyte of swap, and we can have up to 60 virtual disks per virtual machine. That would give us potentially 120 terabytes of virtual disk storage in a virtual machine, so long as we have that available to present to it. Or use thin provisioning, and maybe we don't even have that available, but we can specify that that's what the machine is going to see. There's really very, very few x86 and x64 style workloads that you wouldn't be able to virtualize, either something that's already in your environment or something that's designed to go into a modern rather than legacy x64 environment. We can still virtualize to a very high extent. Now, I have to be careful about how we're going to do resource allocation for those types of applications and how we're going to handle these types of scenarios. But in some cases, we may find that we have a virtualized environment with very low consolidation ratio because they have very, very high workload machines. And we'll talk a little bit more about that in an upcoming slide.